Okay, section 9.2 is reflections. This is another kind of transformation. We've already done our translation, which is like a shift. This is a reflection, which is like a mirror image. So the reflection across a line. And I'm going to have you write all this down. It won't make a lot of sense until we go on to the next slide or so. But a reflection across a line M, called the line of reflection, is a transformation with the following properties. If a point on A is on line M, then the image of A is itself. That is, A is A prime. And that's not really an apostrophe, it's a straight line. A is A prime, and that's how we read this. A prime. If a point B is not on the line M, then M is the perpendicular bisector of the line segment B prime. When you write a reflection across M that takes P to P prime, we denote it as R sub M, reflection over line M of P, is P prime. So that's all our notation. Write it all down, pause if you need to, and then come on back to the next slide. And again, this may not make sense to you yet, but that's okay. Okay, so here's our picture of a reflection over line. I did line N this time. And these are the properties of our reflection. Reflections preserve distance. If a reflection over line N of D equals D prime, and the reflection of line of R DE remains the same distance as D prime E prime. In other words, they don't change the distance of my shape, they just change its position reflected around the line N. So that's one property. Reflections preserve angle measure. If the reflection on line N of angle DEF equals angle D prime E prime F prime, then the measure of those two angles stays the same. Reflections map each point of the pre-image. Remember, our pre-image is what we start with, to one and only corresponding point of the image. So the reflection over line N of D equals D prime if and only if the reflection over line N of D prime equals D. So the reflection from D to D prime would be the same as if I started at D prime and did the reflection to D. And you notice that the distance from E to E prime is separated by line N as a perpendicular bisector. In other words, this distance is the same as this distance. This distance equals this distance. I guess I could do it this way, right? And this distance equals this distance. N is the perpendicular bisector between our points. And notice that this is really a mirror image. That's why we call it a reflection in a mirror. If I folded this paper in half along line N, these two triangles would lay right on top of each other. So that's why we call this a reflection. Okay, so how do we reflect a point across a line? Point P has the coordinates 3, 4. So there's point P. And I want to find the coordinates of the reflection over the line x equals 1 of P. So first I have to find the line x equals 1. There it is. And to do the reflection, the distance from P to my line of reflection And the distance from the line of reflection to my reflection itself has to be the same. So P is 2 units from this line, x equals 1. Therefore, P prime is also 2 units. So the coordinates of my reflection, P prime, would be -1, 4. Pretty simple to do. You will need graph paper. So make sure you have graph paper handy for class and for your homework. Now, what if we want to reflect an entire image? So I have triangle ABC with vertices at -3, 4, 0, 1, and 4, 2. So this is my triangle ABC. And I want to reflect it across the line y equals -1. So there is my line of reflection, y equals -1. And I'm simply going to count my distances. A is 1, 2, 3, 4, 5 units. So 1, 2, 3, 4, 5 units puts me at A prime. B is 2 units. So B prime is 2 units. C is 3. So C prime is also 3. So there is my graph of the reflection and giving me triangle A prime, B prime, C prime. And that's it for this lesson. It's a pretty simple idea. You do need graph paper. Be sure you have